Welcome to the Existing Safety Analysis video for the Missouri Department of Transportation. This video corresponds with the MoDOT Engineering Policy Guide, EPG 905.3.6.1. This video will review the triggers for determining when an existing safety analysis is needed, the types of existing safety analyses, the parameters to be determined before an existing safety analysis is completed, and calculations and analysis techniques that can be used for the existing safety analysis. There are two components of a safety study: an analysis of the roadway's crash history and an estimation of future crashes. The focus of this module is on analyzing the history of a roadway's crashes. This will also be referred to as an existing safety analysis. The following guidance is intended to serve as a resource for practicing MoDOT project managers and consultants when completing or reviewing TIAs when an existing safety analysis component is included. These guidelines are consistent with the department's traffic safety standards of practice. TIAs typically have a threshold to trigger a safety study. This threshold includes 100 new trips to be generated in the peak hour, an identified safety issue in the study area, or any major infrastructure project. Please note that these are rules of thumb. If a safety study is in question, MoDOT will determine the need for the safety study. Also, MoDOT's traffic safety lists can be used to aid in identifying high-risk safety locations. Before completing an analysis, some key parameters need to be defined. The three types of crash history analyses are section analysis, intersection analysis, and network analysis. Depending on the project, one or more types of analyses may be needed. Section analysis is the preferred analysis type for studies where the main concern is mainline crashes along a specific section of roadway. Examples include an interstate corridor or rural secondary road. Section analyses require a begin and end point and include crashes along a corridor between these limits, including intersection-related crashes unless there is a project-specific reason to exclude them. An example of study limits for a section analysis are displayed on this slide. Intersection analyses are the preferred analysis type for the studies where crashes at a specific intersection are the primary concern. Examples include a downtown intersection or a rural driveway access. Intersection analyses typically use crashes within 150 feet of an intersection along all approaches. For MoDOT, this distance is 132 feet of an intersection unless specified otherwise on the crash report. This distance should be extended from the edge of the pavement of the cross street for each approach. They should be used if project considerations are expected to impact these types of crashes. An example of study limits for an intersection analysis are displayed on this slide. It should be noted that the recommended study limits of 150 feet may be extended at the analyzer's discretion to capture impacts at any nearby driveway accesses that fall just outside the standard limits. Network analyses are ideal for situations with both changes in features and changes in traffic patterns and volumes. Network analyses are a combination of section analyses, often with one or more intersection analyses too. An example would be the closing of at-grade crossings while adding a new interchange.
This would likely cause traffic to reroute through a network of sections and intersections, which need to consider not just the proposed changes in features, but also the changes in traffic patterns and volumes.
Parameters to be determined prior to completing an existing safety analysis include the following. Analysis type. There are 3 types of existing safety analyses, and the type of crash analysis can differ based on the project type. Location. Sometimes the specific locations of crashes may not be documented correctly or documented to the level of detail needed to pinpoint its location. The accuracy of the reported location of crashes may need to be reviewed if possible. Locations of crashes should be specifically scrutinized at interchanges to ensure accuracy. Time period. Typically, a study period of the most recently available 5 full years of crash history data is standard for crash analyses. However, there are exceptions to this typical practice. Always check with MoDOT safety engineers to ensure reasonableness. Study limits. As previously mentioned, section analyses require a begin and an end point that should include all affected sections and intersections. At a minimum, include the entire footprint of the project area and extend study limits as needed for all analysis types. And finally, additional resources available. Always consult MoDOT safety engineers when scoping the specifics of a crash analysis. Also, there are additional resources such as the MoDOT Crash Statistics Map that are accessible to MoDOT's partners and consultants and can be used to assist the study and can be found at modatazone.modot.org.
Once the safety analysis parameters have been defined, there are many calculations and analysis techniques that can be used for completing a crash analysis. Calculations and analysis techniques that can be used after completing a crash analysis include segmentation, corridor crash rate, critical crash rate, crash statistics, and crash patterns. Section crash analyses can be segmented as needed. However, it should be done in a manner that ensures the data remains statistically valid when comparing to statewide average crash rates. Due to statewide average crash rates consisting of many miles of continuous corridors, segmenting the data too much may create sample sizes that are too small and lessen the validity of the comparison of the crash rates to the statewide average. In a section analysis, segmentation may be done when the length is not too short, when the cross sections drastically change between corridor intersections, for example, a change in number of lanes, and when there are interstate or highway facilities at the interchange. As a note, segment lengths do not need to be equal, as crash rates will be adjusted accordingly based on length. Example study limits for a segmented interstate section analysis are shown here. Limits may be extended on cross streets as necessary to ensure that all crashes are being considered. Crash rates are calculated using a combination of crash frequency and vehicle exposure. The crash rate is equal to the number of crashes divided by exposure. Exposure is equal to AADT multiplied by the number of days in a year, number of years, and the segment length in miles. Crash rates are expressed as either crashes per 100 million vehicle miles traveled for section analyses, or in crashes per 1 million entering vehicles for intersection analyses.
Statewide average crash rates should be used for comparison to the corridor crash rate when available. The statewide average rate used for comparison is up to the analyzer's discretion and should be one that best represents the characteristics of the study corridor. For example, occasionally, U.S. routes will function more similarly to the state or secondary road than to an interstate facility. Note that if there is a situation where a change or deviation occurs, then concurrence from the review team should be obtained. When appropriate, and after discussing with the project team, it may be necessary to convert statewide average crash rates to critical crash rates to remove the elements of chance and randomness. This conversion helps determine whether the corridor crash rate for a segment is significantly higher than the rate of other locations with similar characteristics. If corridor crash rates are equal to or greater than the critical crash rate, then the crash rates may be considered significantly higher than the average and not due to chance or randomness. The critical crash rate is calculated as follows. The critical crash rate is equal to the statewide average rate plus k times the square root of the statewide average rate divided by exposure. This is then added to 1 divided by 2 times the exposure. K is equal to 1.645 and is the probability factor for a 95% confidence interval. Note that exposure is specific to the site being evaluated and uses the same formula as provided on slide 14. Results from the crash analyses should be summarized in a report format. Crash analysis results should include, but are not limited to, total number of crashes, crash rates and comparison to statewide average crash rates, crash types and percentages, crash severity and percentages, and a map of all study area crashes. Note that systemic safety treatment or risk factors are always something to be aware of. While a crash may not have occurred yet, it could be beneficial to identify potential risk factors that could contribute to a crash. For more information, refer to EPG Article 907.1.1 and Missouri's Strategic Highway Safety Plan.
The crash analysis should be reviewed to determine if specific crash patterns exist and are outlined in the traffic analysis report. Crash reports should be reviewed as needed to determine location and accuracy of information. Patterns can include, but are not limited to, time of day, day of week, light conditions, pavement conditions, pedestrian and bicycle crashes, and crash type. The revisited key takeaways from this module include triggers for determining when an existing safety analysis is needed, the types of existing safety analyses to be aware of, parameters to be determined before an existing safety analysis is completed, and important existing safety analysis concepts to be aware of, especially when reviewing the analysis after it has been completed. There are several resources available to you as you perform an existing safety analysis.
MoDOT has a goal of 0 fatalities on Missouri's roadways. The game plan to achieve this goal can be found in Missouri's Strategic Highway Safety Plan. Show me 0.
The MoDOT EPG contains an abundance of information about conducting an existing safety analysis. You can locate the safety analysis portion of the MoDOT TIA Guidance Manual in EPG 905.3.6.1. Additional information can be found in the resources listed here. Time to see what you know.
Question 1. What triggers a safety study? A. 100 new trips in the peak hour. B. An identified safety issue in the study area. C. A major infrastructure project. D. A MoDOT determination that a safety study is necessary. Or E. All of the above. The correct answer is E. All of the above.
Question 2. Which of these is not a type of crash history analysis? A. Section analysis. B. SIDRA analysis. C. Network analysis. Or D. Intersection analysis. The correct answer is B. SIDRA analysis.
Question 3. When can crash rates be considered significantly higher than the average and not due to chance or randomness? A. Corridor rates less than or equal to critical rates. B. Corridor rates less than or equal to statewide rates. C. Corridor rates greater than or equal to critical rates. Or D. Statewide rates greater than or equal to critical rates.
The correct answer is C. When corridor rates are greater than or equal to critical rates.
Question 4. Which of these is not a valid crash pattern that can be reviewed? A. Make and model of vehicle. B. Pavement condition. C. Time of day. D. Light conditions. The correct answer is A. Make and model of the vehicle.
Thank you for watching this video on TIA guidance for existing safety analysis. We encourage you to view the other TIA guidance videos. If you have any questions, please reach out to MoDOT Central Office Highway Safety and Traffic.